Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about elements and their classification. So we are discussing about here the earlier classification of elements. What is the necessity for the classification of elements? What are the advantages of classification of elements? And Lavoisier's classification into metals and non-metals. This we have seen in the earlier sessions. Now we are going to see about some other earlier attempts for classifying the elements we are going to see here. They are Daubernier's Triads classification and Newland's Octaves classification. First of these, let us go with Daubernier's law of triads. After the development of atomic theory and the determination of atomic masses of a large number of elements, attempts were made to classify the elements on the basis of atomic masses. So after determining the atomic masses and atomic theory, scientists they have tried to classify the elements based upon their atomic mass. So a German chemist and professor Daubernier's attempt in 1817 for the classification of elements is generally considered as the first recorded attempt. So he tried to classify the elements based upon the property atomic mass. So he identified elements with similar chemical properties. So he identified three elements which are having same type of chemical properties and he grouped them into a group of three. Hence, these are named as triads. In the honor of his name, they are known as Daubernier's triads. Triad means a set of three elements which are having similar chemical properties, similar properties. So he realized that when we arrange these three elements according to their atomic weight, means if these three elements are written in the increasing order of their atomic weight, the atomic weight of the second element was roughly the average of the atomic weights of the first and third elements. What is it here? When the three elements which were categorized as one set and having similar properties, if these three elements are written in the increasing order of their atomic weights, the atomic weight of the, surprisingly it is observed there, the atomic weight of the middle element is exactly equal or roughly it is equal to the average of the atomic weights of the first and third elements. That we say as the arithmetic mean of the first and third elements atomic weights is equal to the atomic weight of the second element or middle element. The group of such three elements were called as Dobereiner's triad. Okay, see here some examples for the Dobereiner's triads are given. One of the triads is lithium, sodium, potassium. Dobereiner observed these three elements are having similar properties. And now he arranged these three elements in the increasing order of their atomic weights. And it is observed here the atomic weight of the middle element is sodium is equal to the arithmetic mean of the atomic weights of remaining two elements, that is first and third elements. The average of the atomic masses of first and third elements atomic weights is equal to the atomic weight of second element. See here the atomic weight of lithium is 7 and for that of potassium is 39. The average if it is taken for these two, that is arithmetic mean, it is equal to 23, which is the atomic weight of sodium. Okay, in the same if you see for remaining groups also, the arithmetic mean of the atomic weights of the first and third elements is nearly equal to the atomic weight of middle element. So in this way, he arranged those three elements as one set and he called those three elements as one triad. So these are called Daubernier's triads. Okay. So even though it is classified, there are certain disadvantages or we can say as drawbacks in this classification. Let us see what are those disadvantages in this Daubernier's triad. The main drawback of this classification was that the concept was not applicable to all the known elements by the time, but only to a limited number of elements. So Dobereiner could classify only some elements into these triads. He could not classify all the available elements at that time into these triad sets because their chemical properties are being different. Because of that, he could not classify all the known elements at the time into these triads. Only limited number of elements only he could classify into triads. This is a major drawback we can say in this Dobereiner's triad to avoid this. In some triads, all the three elements possess nearly the same atomic masses. Hence, the law was rejected. So, if all the elements are having a nearly same mass, then automatically it comes there, but properties might be different there. So, this triads law is rejected in that case. However, one point became clear that properties of the elements have some relationship with their atomic masses. So, this point came to know then. Even though it is failed, it given one information. That is, the properties of the elements are having certain relationship with their atomic masses. So in that way, the scientists they have started studying the properties and their characteristics in this way by taking the atomic mass as a standard unit. Okay. Next, another classification. The earlier attempt was done by Newland. This we say as Newland's law of octaves. John Alexander Rena Newland was a chemist as well as a lover of music. He arranged many of the known elements in the increasing order of their atomic masses. So he also arranged the almost all the known elements in the increasing order of their atomic masses. Then it was noticed that the eighth element was similar in properties to the first element. So the properties of the first element are being resembling with the consecutive eighth element in this order. When all the known elements if they are written in the increasing order of their atomic masses, the properties of one of those elements are being resembling with the consecutive eighth element to it. So just like the eighth note in the music, we know the musical notes in the Indian or Western, we take the Indian music. The notes are like this: Sa, Re, Ga, Ma, Pa, Da, Ni, Sa, isn't it? So there, the first note is Sa, and after that, the consecutive eighth note for that is again Sa. Means it is being similar, first and eighth. In the same way, when the elements are also arranged in increasing order of their atomic masses, the properties of the first element are resembling with the consecutive eighth element to it. So he called this set of eight elements as one octave in that way, one octave. In honor of his name, they are called Newland's octaves. Octa means eight, we know. The set of eight elements is called octave, where the properties of the first and eighth element are being resembling one with another. See here, that elements are mentioned. If we see lithium, we have to remember one thing here. While he was giving this classification, noble elements were not found at that time. So, whatever the elements were found by that time, he arranged them in the increasing order of their atomic masses or atomic weights. Then he observed the properties of one element are resembling with the consecutive eighth element to it. For example, if you see here lithium, for this lithium, after writing all the available elements in increasing order of their atomic masses, the consecutive or the next eighth element for lithium is sodium if you count 1, 2, 3, 4, 5, 6, 7, and 8. So for lithium, the consecutive eighth element is sodium. Now it is observed here the properties of lithium and sodium are being similar. And if you take sodium, for this the consecutive eighth element is being potassium if you count. And it is observed here the properties of sodium and potassium are also being similar. In the same way, if you observe nitrogen, for the nitrogen, the consecutive eighth element is phosphorus. The properties of phosphorus and nitrogen are observed similar. And if you see fluorine, For fluorine, what is the consecutive element in this set? Chlorine. The properties of chlorine and fluorine are observed similar. In this way, when elements are written in the increasing order of their atomic weights, the properties of one element are resembling with the consecutive eighth element to it. In that way, it is just like the musical notes. If you see here, these are Indian musical notes. For this first one, the consecutive eighth note is again sol. These are same. In the same way, elements order also. For one element, the consecutive eighth element is having similar properties. In that way, it is compared with the musical notes. These Newland's octaves. Okay. And if you see the first one, the eighth element after lithium is sodium. It is similar to lithium in many of its chemical properties. Similarly, the eighth element after sodium is potassium, just now I have seen. So, whose properties are similar to sodium. In this way, one element is having similarity in its chemical properties with the after the continuous eighth element to it. So, he called this set of eight elements as one set and it is named as octave, which we call as Newland's octaves in the honor of his name. And if you observe, the eighth element from fluorine is chlorine. Both are having similar properties. Fluorine and chlorine both are having similar properties, isn't it? And the eighth element from nitrogen is phosphorus. And both nitrogen and phosphorus are having similar properties. Okay, in that way, they are called as octaves. Based on this observation, Newland stated his law of octaves as when elements are arranged in the increasing order of their atomic masses, the eighth element resembles the first in physical and chemical properties, just like eighth note on musical scale resembles the first note. Just like the musical notes, these elements are also resembling their properties of the consecutive eighth element. So he called these as octaves. So here, this statement is known as Newland's law of octaves. That is, when elements are arranged in increasing order of their atomic masses, the eighth element resembles the first element in physical and chemical properties. This is known as Newland's law of octaves. So the achievements of this law of octaves are few here. The of octaves was the first logical attempt to classify elements based upon the atomic weights. Okay, this is after arranging the elements in increasing order of the atomic weights. The logical attempt was done by Newland here to classify the elements into octaves. So we can say this Newland's octaves classification was the first in attempting the classification of elements based upon the atomic weights. Periodicity of elements was recognized for the first time. This is very important. Periodicity was observed in this. So when elements are written in the increasing order of their atomic weights, the properties of one element are being repeated by some other elements in that order. Some other elements in the consecutive eighth element to that. The properties are being repeated by some other element in that order. That repetition of properties from one element to some certain element was known as periodicity. Reappearance of properties from one element to another element in the order at certain intervals is known as periodicity. So this periodicity in the properties of elements was first time recognized in these Newland's octaves. Okay, this we can say as achievements of law of octaves. But it is also discarded because of certain disadvantages or drawbacks. Let us see what are those disadvantages and drawbacks in the Newlands classification. The major one is this law could be best applied only up to element calcium, even though many elements were known by that time while he was giving this classification. But it is best applied till calcium only. For higher elements, it could not be applied clearly, accurately. So it is also limited for few elements only. Okay, that is major drawback we can say. Another one is newly discovered elements. Especially we can say noble gases could not fit in the octave structure. For example, if you see, we told after lithium, the consecutive eighth element is sodium. So because here lithium, beryllium, next boron, carbon, nitrogen, oxygen, fluorine. While he was giving this classification, as we told, they didn't come to know about noble gases yet. So after fluorine, they know about sodium. Now, for lithium, the consecutive eighth element is being sodium, and the properties of these two elements are observed similar. So he called this set of eight elements as one octave. But when noble gases are discovered, one element neon is fit in between fluorine and sodium. Now for lithium, the consecutive eighth element it became neon, not sodium. But whereas the properties of lithium and neon are being entirely different from one to another, isn't it? Lithium is a highly reactive metal, neon is a least reactive noble gas. But for lithium, it became now eighth element neon. So the octave system is completely disturbed. It is not followed here, isn't it? So by the discovery of noble gases, this octave theory is completely failed. So this is one drawback we can say. It failed to exhibit this feature with the heavier elements, as we told in the first point here in the disability. It is applicable. This best applicable only for few elements till calcium. It is not applicable for the heavier elements. It is not fit for that higher elements. So we can say these are the drawbacks by which this Newlands classification is discarded. However, a very important conclusion was made that there is some systematic relationship between the order of atomic masses and the reputational properties of elements. So this was found by this Newland octaves classification. Even though it is failed, it has given one clarity. That is, there is certain relationship between the atomic masses of the elements and their properties. That is, when elements are written in the in order of their atomic masses, there is a certain repetition of the properties of one element with some other elements. That was observed here. That we call as periodicity. This gave rise to a new term called periodicity. Periodicity in the sense repetition. Here it is found here the repetition of properties of one element with another element. That is called here periodicity. It was found for the first time in the Newlands octaves. So it is a periodicity is the reoccurrence of characteristic properties of elements when arranged in the table at regular intervals of a period. When elements are written in the increasing order of their atomic masses, the chemical properties, certain characteristic properties are being reoccurred from one element to another element. This they call as periodicity. It was found for the first time from this Newlands classification, even though it is having certain drawbacks. Okay, this led to the another further classifications. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded videos.